Section 4.1 is on divisibility. We're going to look at different divisibility rules that may make it quicker to find out if something is divisible by certain numbers. So we're going to start off with the divisibility rule for 2. If a number is divisible by 2, then its units digit is divisible by 2. It also means the units digit is even. So if I'm looking at this first one, and I want to know, is it divisible by 2? I just look at the last digit and say, yes, it's even. So then, yes, it's divisible by 2. The next one, divisibility test by 5, is very similar to this one. We're going to look at the last digit. And if the last digit is divisible by 5, which means it is a 0 or a 5, then it is divisible by 5. So this one, its last digit is 5. So then our answer would be yes. The next one, divisibility by 10, means the units digit is divisible by 10, which just means it is a 0. So then, if it ends in a 0, it is divisible by 10. Now, what else is this divisible by that we've talked about so far? It ends in a 0, and that means it is an even number, so it's also divisible by 2. And then remember, to be divisible by 5, it has to end in 0 or 5, which it does. These three rules are very similar because we're just looking at the last digit. So I kind of put those together. The next two rules, divisible by 4 and divisible by 8, are very similar. So the divisibility test for 4 is we're going to look at the two rightmost digits. And if those are divisible by 4, then the whole thing is divisible by 4. So in this one, I will be looking at 24. And 24 is divisible by 4. It's 6. So then we say, yes, the whole number is divisible by 4. Again, we can look at the other rules we've talked about. It's an even, so it's also divisible by 2. It's not divisible by 5 because it doesn't end in 0, 5. And it's not divisible by 10 because it doesn't end in 0. Now, if we're looking at the divisibility test for 8, this time we're going to look at the three rightmost digits and see if they are divisible by 8. If they are, then the whole thing is divisible by 8. So we're looking at 128, which is divisible by 8. We would get 16. So therefore, the entire number is divisible by 8. It's also divisible by 2 because it's even. And by 4, because if you look at the last two digits, 28, 28 is divisible by 4. It's not divisible by 5 or 10. The next two rules go together. Okay, the divisibility test for 3. And a number is divisible by 3 if the sum of its digits is divisible by 3. So in this example, we take 23,541 and we'd add the digits, which would give us 15. And 15 is divisible by 3. We'd get 5. Therefore, we'd say yes. It is divisible by 3. If we look at this one further, it is not divisible by any of the other numbers we've talked about. It's not even. It doesn't end in 0, 0, 5, or 10. The last two digits are not divisible by 4, and the last three digits are not divisible by 8. So this is only divisible by 3. Divisibility test for 9, like I said, I'm going to pair those together. This is very similar because, again, we're going to take the sum of the digits and see if it's divisible by 9. So I have 5 plus 1 plus 2 plus 4 plus 9 plus 6. When I did that, I've got 27. 27 is divisible by 9 to get 3. So, yes, 512,496 is divisible by 9. We can look through some of the others we've talked about. It's even, so it's divisible by 2. It's not divisible by 5 or 10. But if we look at 4, 96 divided by 4 works. 496 divided by 8 works. And it's also divisible by 3 because remember you add up the digits and 27 is divisible by 3. The next one, divisibility test for 6. The number is divisible by 6 if it is divisible by both 2 and 3. So we can decide if this is divisible by 2 and 3. So we start off with it's even. So it's divisible by 2. Then we're going to add up the digits, which gives us 18. 18 is divisible by 3. Therefore, it's divisible by 6. Other numbers this is divisible by are 2, because it's even. 4, because 36 is divisible by 4. 3, which we found right here. It's also divisible by 9 because 18 is divisible by 9. The next one, the divisibility test for 11. If you read out the rules for this one, it's kind of confusing. So it says a whole number is divisible by 11 if and only if the difference between the sum of the digits in the places that are even powers of 10 and the sum of the digits in the places that are odd powers of 10 is divisible by 11. Goodness. Okay, so what we're going to do, what this really means, is you're going to go through and take every other digit and add it together. So we're going to start with 5, plus then 3, and then 6. When you add those, you get 14. Then we're going to add the digits that are left, 8 plus 9, and that gives me 25. Then subtract biggest minus smallest, so 25 minus 14 is 11. And you see, is 11 divisible by 11? We get 1, so yes it is, which means the entire number is divisible by 11. I encourage you to pause it and try the next one on your own. We start by adding every other digit, so we do 2 plus 7. That would give me 9. And 6 plus 3 also gives me 9. When I subtract, I get 0. And 0 is divisible by 11. Okay, this one I always have people that have trouble remembering. So I want you to remember, if 0 is on top, it's okay. This will be 0 over 11. We get 0. If the 0 is on the bottom, we get the word no, and that's not allowed. This is undefined. Now, there's no worksheet with this section, but I do have one more problem, putting all of this together. So I would like you to pause the video and try this on your own. Okay, when I'm looking at these problems, I'm just looking for a yes or no. You don't have to show any of the work, but I will give you large numbers that won't necessarily work in the calculator. So I will know if you use the rules or not. So the first one is the number divisible by 2. Our answer would be yes. And the reason is because it's even. So remember, I'm just looking for yes or no, but I'm going to show you the reason why. The next one, divisible by 3, we would go and add up all of the digits in the number, and you should have come up with 60. 60 is divisible by 3, so we say yes here. To be divisible by 4, remember we looked at the last two digits. 84 is divisible by 4. We get 21. So then we put yes here, like it says on the. Is it divisible by 5? We'll say no. And the reason is because it does not end in 0, 5, or 5. Divisible by 6, we say yes. Okay, the reason is divisible by 2 and 3. Being divisible by 8, remember we look at the last 3 digits. So the last 3 digits are 584. That is divisible by 3. Then we say yes, this is divisible by 8. Looking for 9, we take the sum we found in number for testing 3, which is 60, divisible by 9. It is not, so our answer is no, it's not divisible by 9. It's also not divisible by 10 because it doesn't end in 0. And the last one, 11, you're going to take again every other digit. 5 plus 7, 9, 6, 5 plus 4. I get 36. And the other digits, 7 plus 2 plus 4 plus 8. That gives me 24. 36 minus 24 is 12. 12 is not divisible by 11. So the answer to this one would be no. So again, I'll be looking for yeses and nos, but make sure that you use these rules, because sometimes it's on the calculator. If you put this large of a number in there and you divide it by one of these numbers, it will either give you an error or it will round the answer. And it'll look like it's divisible, but it's actually not. So just be careful of that. This concludes section 4.1. If you have any questions on the homework, please feel free to use the Ask My Instructor button.